It's on now.
Wasn't on?
It was off. Now it's good.
Okay, my microphone was off. The online one. Okay, so I'll just repeat that again. Assignment 1 marks will be out later today. Make sure you don't just look at the mark actually. Make sure you look at the feedback. In case there's any feedback that you can take on board for the next assignment too, right? So that you'll get a style mark, other comments. So have a look at those comments and that feedback. All right, my experience, you should have got an email this morning sometime maybe. So we love getting your feedback. So I hope that you can take some time at some point to fill that in. All right, last set of revision sessions are on next week. I don't think they've come out on Ed yet, so keep your eyes posted because there'll be links and sign-ups there, and probably voting for your favourite topic. All right, next week in the lab, we've got practice exams. So they can't be done online, they have to be done in face-to-face labs. So if you're in an online tutor lab, we've got a way you can sign up to come to a lab in person for next week, okay? And I really recommend that if you're in an online lab, sign up. And again, this is already on Ed that you can sign up. Sign up and come to an in-person lab if you possibly can, because this practice exam will be in the exam environment, the same exam environment that you'll be doing the actual exam in. So you'll know exactly what you can and can't access during the exam, which is always everybody's question, if you come to the practice exam, all right? So yeah, go to that, you'll get a good idea of what to expect in the real exam. That's really the best thing you can do. Any questions about that? Now, yeah, you get lab marks for doing it. It's not based on getting like 100% in all the questions. We're not marking your questions for quality. We're not marking for correction. It's just you need to attempt this practice exam, okay, to get the lab marks for the week. All right. So last week we did a lot of stuff about linked lists, inserting nodes, deleting nodes. Today's lecture, I do want to do a bit of a recap on linked list deletion and do some of the things that we didn't get a chance to finish last time. But we're also going to do a larger application. So this is going to have linked lists with sort of more complex data rather than just integers. And it's going to be in like an application rather than just isolated single linked lists with an integer in them. So like your assignment in that respect. And it's in multiple files, and hopefully it will help with assignment 2. So I want to get started with that now. If I just spend the whole 2 hours doing that, your brains will kind of just, not cope, either will mine. So I'll do that, then we might do a Kahoot, then we might come back to it, recap a deletion when it's appropriate for this application and see how we go. All right, the code's there. As always, there's some starter code. I'm skipping this for now, but I will come back to it. So this is an email management system. So this probably doesn't seem to have anything in common with a CS dungeon game, like just from the title, an email management system. And we don't want it to just be another game that's sort of almost the same, just with different characters in it or something. So this actually has linked lists instructs, strings, all the stuff. It's just, a different problem. And I guess a more sort of practical problem. So in this, like in assignment 2 actually, there's 4 files. So there's a .c file, the email management system.c file. That's the file we're going to be implementing today, writing all the functions that haven't been written in that. There's an email management system.h, which is provided, and I'll show you that in a minute. It has all the structs and prototypes and enums and stuff like that. Then we've got 2 mains. Now we've got the main that sort of does something somewhat useful. It's not the fanciest email system, it's very simple. And that's provided. And we've also got just a test main. We've got a file that just tests stuff by printing out details. So I'll just quickly show you all the different files that we've got. Let me bring this out a bit. Because the first step is always to really understand what on earth you're doing, what you've been given, what it does, how do I compile it, how do I run it. So here we've got our email management system.h, and all these fine details don't matter right now, but it's got hash define, some enums, so there'll be different email types, draft, received, sent. There'll be different email priorities, low, normal, high. And then one thing that's important in here are the structs. I'll go over the structs in more detail in a minute. But then we've just got all of these prototypes. All right. Now, this email management system.c hash includes this .h file. So we hash include .h files, in whatever related C files that are sort of using those structs and enums, whatever. All right, so that's been set up, and this is where we implement the functions that haven't been implemented. We can add helper functions. Again, like in the assignment, we don't want you to just always do each function in that one function. It's often helpful to create a helper function, and it might be useful for lots of the different functions you might find. So we can add prototypes and add extra functions as well. And then we've got two mains, like two files that have main functions in them. So we've got this main, which tries to do something sort of useful that a user might interact with and add emails and print emails out. And then we've got this one that has a main, but it's just purely testing things. It's purely creating structs, printing out their values, and you're able to look at that output and see if it's correct. So we're not setting up in any automated test framework here. You'll be doing that in other courses, but we're just doing the kind of testing that I think you've got in assignment 2. You've got something that can help you test stage 1, and it's just a main. So it's sort of similar in the style of what files we've got. Okay, so the first thing, understand the problem. What are you supposed to do? Now, I haven't written up a whole long spec with all the details like in the assignment. I'll talk us through what we're doing in that respect. Oh dear. Okay. And also as we're going, before we're going, while we're testing and debugging, we want to keep drawing diagrams of anything we're trying to understand or debug or code up. This is really helpful for linked lists. And also, we're always going to be thinking, what if this list is null? What if, it's the last one in the list? We've got to keep all of these things in mind, the different types of test cases. All right, now in this particular problem, we've got two structs that we're dealing with. We've got a struct folder. So we can have folders for our emails, and then we can have individual emails. And notice, because this isn't a real email system, we don't actually have the email content in this struct. It's too hard trying to just make up fake content. So we've just got sender, subject, size, types, priority, and this field to the next. So which of these structs represents a linked list? And why? Yes, so this email, struct email, has a pointer to another struct email. So this is the struct that can potentially, and does, represent a linked list, right? It's got a pointer to another struct of the same type. So in this program, we're going to have a linked list of emails or many linked lists of emails. This one over here, could this be used as a linked list itself? No, this is a folder and it contains a linked list, or it contains a pointer to the head of a linked list. Okay. All right, so once we start doing this, sometimes people can get a bit confused because they just started with linked lists. We clearly had linked lists called node, struct node, and here we've got all these different names and they're buried in other structs. The same with the assignment. All right, now if we try and visualize how these structs fit together, we can have a folder, which is a struct. Now there's one field in here that we'll be using later that we won't be using at first. It's still in the drawing, but a folder's got a name, and it may or may not keep count of the number of emails. But the most important thing it's got here is this. This is our linked list. And at the beginning, if you create a folder, we should have an empty linked list just pointing to null. So this would be a folder we've just created with no emails in it yet. Is everyone happy with that? Now, once we start adding emails, we'll end up with something that looks like this. We'll still have our folder, and the linked list containing the emails will actually have email structs containing different emails in there. All right? Any questions about this so far? Is this my laptop? Did everyone hear that? Thought somebody turned on like a hairdryer or something. Let's just see how we go. So yeah, we've got a folder, we'll have some emails in it, and it'll look like this. Yeah, question?
I was wondering whether this is going to be reflective of what our final exam is like. Is it like reflective of what our final exam is going to be like?
This is reflective. The question was, is this reflective of what our final exam will be like? No. This is reflective of what an assignment might be like, but this is like a bit easier and more simple. Yeah. So you wouldn't be doing this whole system put together really as one of the exam questions. You might be doing a part of it, like one of the functions. That would be an exam question. This is like having about 10 different exam questions in one, like the assignment, you know.
I expect the exam to be like this, and then you run another test, and that's your exam.
No, it'll be like the labs where you get individual questions, and some of them will, and we'll talk all about the exam later, but this is more like an assignment, but some of these individual functions could be something you'd get in an exam, but we wouldn't do the whole thing, because this actually might take, we might not finish, we're not going to finish this in the 2 hours probably. Yeah. All right, so given this structure, how could I access the head of my linked list of emails? So if I had a folder called My Folder, how would I get the head of the email list that's in that folder? So if I've got something like, I've got a variable of type struct folder. I'm just going to call it, I've called it My Folder. And it's been created somehow, but we've got this variable of that type. Well, my folder, and this is a struct, right? So my folder is pointing to some chunk of memory. I've got a pointer to it. So if I access anything, if I've got a pointer to a struct, I use arrow. Now, what's the field that has the linked list in it? Emails, that's right. So this here is basically the head of my list. Is everyone clear on that? This will be important. So usually we give you, and it very clearly says head of list or whatever it says. Here, this is buried in here. To get it, we have to say my folder, arrow, emails. This is our linked list, the head of our linked list. Any questions about that? Yeah, so like in assignment 1, we're going to have to malloc that folder struct. And then, you know, like with any linked list, we'll be mallocing all the emails, which are nodes. So here, this is like our struct node, right? But for emails. Okay, yeah. So then we can have more than one folder, right? But we'll get there later. Now, how do I compile and run all this stuff? I've got 2 files that contain main functions. you can't compile them all together. Has anyone tried? You can't compile together multiple files that have mains in them. You get compiler errors. But what we do is I can compile together, like this is the code that sort of has all the, it's in a way like our own library code. This is the code that has the main. I compile all that C code together and I'm calling this test main, and then I can run it. So I can run all the code in this main file by compiling it together like that and running it. If I want to compile the other main, I have to compile it again. Here I'm putting this email management system together with this other main, and I'm compiling it all together and calling it main, and then I can run it like that. All right, so again, this is what you need to do with assignment 2. For stage 1, you've got some kind of test file. You would just compile that and the C file you're using to run that. If you're trying to run the whole CS Dungeon program, you compile that part separately like this. Yep?
Does the order matter?
No. Like, do you mean I could have this here or this here? Yeah, that doesn't matter. As long as you've got all the relevant C files and you don't have additional C files that have extra mains in there that you don't need. Yep. Okay, so we're going to start, well, I've just put it into 2 little stages, but let's just get started. So I've got my email management system. The first step is we just want to create a folder. So again, I'll go back to this picture here. This is basically an empty folder. Ignore this field that doesn't exist yet. So what are the steps I have to do to create this folder? Yeah, malloc. So first of all, I do a malloc, and that's going to create a chunk of memory. Then what do I have to set inside it? I have to set all of the fields. So I'm going to have to set the data for the name, whoever's passing that information into the function tells me. And it's going to be a new folder. What will my emails field be equal to? So when I've got nothing in the folder, emails will be pointing to null. So all I have to do is malloc the folder and set the data inside it. And I have to make sure I set all the fields that exist, because otherwise at some point I'm going to get some kind of uninitialized variable or something. So yeah, the type of the struct is struct folder. I'm just going to call it new folder, malloc, size of, struct folder. Now in real life, I recommend to check whether your malloc worked. In the assignment and in the exam, we're not going to test you on that. You can leave it out. But if you're doing something in a real life application, please check it. So now I need to set the name inside my new folder. So I've got my new folders here. There's like a chunk of memory that I can put the name, and the name's been passed into here. Now the field is called name. So there's a field in this folder called name, and I'm passing in a string also called name. So you're going to want to do this, right? You're going to want to do this and go, why doesn't this work? Yeah, we've got to use string copy. We can't just use equals with strings. And also, look, often you might be told to be careful about just blindly copying things. In the assignment, you were told you don't have to error check. So usually I would use str and copy and cut the rest of, anyway, we can just do it like this and in the exam. When you get to 1521, you can't. You've got to be very careful. You'll be error checking strings don't overflow. All right, what have I done wrong here? I've typed in name twice. So here we're string copying the name into this struct, and then we've got to make sure, even though it didn't pass in anything to set for this emails field, we've got to realize, well, this is a linked list. It's not going to have anything in it yet, and we need to set it to null. Okay, so now we've made that folder and we return it. So this is sort of the stuff that you are doing in stage 1 of the assignment. Let me know if you've got any questions. And yeah, let me know if there's any questions online that might be appropriate to bring up here, Brianna and Tim and John. Yeah, let me know if there are any questions that come up online that might be helpful. Yeah. All right. If there's anyone online, I don't know if there is. The next one, and again, this is something that you should know. Hopefully, you know that you've done it. Whether you could do it, you would have seen it before. So we want to insert an email at the head of the list. Okay. So we've got some kind of, we've got an email folder. Let me go back to here. We've got an email folder. It may or may not have emails in it already, but we need to create an email. And then we need to, I'm just going to call this new email. Then we need to link it up to the head of the list. So we would be connecting this node to here, right? And then saying, actually, the emails start at this node now. Something like that. Now, to create the node, I could just do all my mallocing in here, but it might be nice to create a helper function to create our node, to do the malloc and set the fields. There are actually a lot of fields in here. So I'm going to do that. So when I say create node, our nodes are the emails in this case, struct email. And I'm going to call it create email. And it needs to get all of this information, which is quite a lot of data. What else, what might we put in here if we're creating a node? So often we have a way to set the next field when we're creating our node. We don't have to, but I think we should. Okay. So we're going to have something like this. It's up to you how you do. Oh, this is meant to be a prototype. I'm getting carried away. All right. Now I want to go and maybe write this function. So apologies for all the scrolling, but I'm going to go down here and put it where the functions go. I should probably put a comment, but I don't have all day, so I'm going to just not. Okay. Now, here, this is just creating an email. This is like create node. So again, what's the first thing we do? We malloc. Then we just set all of these fields inside it. That is all we're doing. So let's, tell me if I'm doing something wrong. Struct email, new email. I'm going to malloc it. Yep. Now I need to set all these fields. Oh, that's the wrong spelling. Let's do it in an order that they've got it here, sender. So I've got to do a string copy to set the sender. I've got to do a string copy to set the subject. I've got to do, I don't have to do string copies anymore. Size equals size, type equals type, priority equals priority, and even next equals next. So whoever's using this function will work out what the next one is, not us writing this function right now. My future self will work that out. Okay, I think I've set all the data inside it, and now I'm going to return that new email. Okay. I'm counting on you to point out anything silly I do, any typos, anything. All right, now back up here, this is where we're trying to insert it at the head of the list. So remember, the head of the list is actually inside this folder. This is what's the head of the list, right? Okay. Now, actually, the first thing I might do is actually use my function I just wrote. What did I call it? Create email. And I need to pass in all of this data. Sender, subject, size, priority, type, priority. And what am I going to put in for next? I'm just going to put in null for now. And yeah, if we're trying to think about style, we might, I kind of like it like that anyway. All right, we've created our email. Now we've got to connect it up. So remember what we're doing. The first step is we want to connect this to the emails that we've already got, I think. Let's try that. So we're going to say new email, next, is equal to basically the head of the email list that we've already got. So we've got a whole lot of emails. We're putting the new email. All the ones that are already there are going to come next. Okay. But now, this is the first one in our email list. So we need to update what the head of this email list is, and it's now our new email. Now we don't have to return it because every time we update the head of the list, we're updating that folder. That folder's keeping track of the head of the list rather than us just returning things like we've done before. Do we think this sort of works? How are we going to know? We shouldn't go very far. In fact, I shouldn't have even written two functions without compiling. Let's start with the test, the one that's just testing things. Test main, email management system.c. Compiles. What are we looking for? We don't even know, do we? But this, I haven't really showed you the test file, but it's going to, let's see what the output is. So it's created a folder. And it says in the empty folder there are 0 emails. And it's printing out there are no emails. Then it's inserting emails into our folder, and then it's printing them out. Okay, let's just have a look at the code though. Do I have this code here? Yeah. So, yeah, I've just created an empty folder. So that seemed to have worked okay. And we've already got supplied code that counts the emails in it, and it's saying 0. We've got something that prints emails that's saying there's no emails, and that's all good. Then we've inserted all of these nodes into our list. So when we're looking at this output, we've got to know what we're expecting. Now, because we inserted them at the beginning of the list, we're not going to get it in the order of John, Tim, Brianna, Tammy, Tammy. We're going to get it in reverse order with Tammy, Tammy, Brianna, Tim, John. Yep, so we've got this list. Sorry, I just wanted to say hello to you guys. Because this is Tammy's code. I've stolen this from Tammy. Tammy made up part of this example and I've used it. All right, Tammy's in there a lot. Okay, so we've got all of that. It seems to have added them to our email list appropriately, and it's counting that there's 5. So this is all looking okay so far. This isn't testing it thoroughly though. Any questions? All right, the next function we want to do is to just search. We just want to search for a specific email. So remember, if we're searching, we're probably just going to do a traversal. We'd start here and like make current equal to the first node in the list. We're just checking, is this what we're looking for? Is that subject the one we're looking for? If it is, we're done, we've found it. If not, we keep looking until we get to the end of the list. So we either get to the end, we didn't find it, or we find it at some point. Now, in this particular version that we're writing, we're not just returning 1 or naught, we're actually returning the node if we find it and null if we don't. So we're going to do something like this that you would have seen quite a few times. Remember, this is getting the head of the list. And then we'd be saying something like, while current is not equal to null, we want to check. Oh, we're checking the subject. So again, we might be tempted to check if current subject equals the given subject equals, and maybe this might compile. This isn't what we want though. How do we want to compare strings? Yeah, string compare. So we want to use string compare. So I just do it like this and put a comma here. And again, if you leave it at that and forget, you're going to get sort of the backwards answer. So we want to say, is that equal to naught? It will return naught if the strings are the same. Okay, so if these are equal, we're returning this current node. We're returning a pointer to that node. That node has this, well, at least the first. Then if there's more than one subject, we're finding the first one that we find. We're returning the first one we find. If we get to the end, we didn't find it, and we're returning null. Okay, let's try it. Oh, what have I done? Or what have I not done?
You have to like set current to current.
Yeah. Yep, so I didn't do this on purpose, and it's good that you knew exactly what it was. Yeah, this is why it's just hanging. As soon as I saw it hanging, I thought, oh. So, yep, I forgot to put current equals current next. Excellent. All right. Let's try it again. Oh, right. It's done a whole heap of stuff I forgot it does. So we were, right, we searched for a subject with AAA and we found it, John AAA. We searched for DDD, we found that. We searched for EEE, we found that. We searched for a subject holiday, we didn't find it. So we've searched for one at the beginning, the end, the middle, and one that wasn't in there, you know. And that seemed to work. Meanwhile, after that, we have also created a second folder and added more data to that. So we should check it properly that that's the correct output. Grace, Andrew, Olivia, Chloe, Tammy. That looks right. Okay, any questions before we go on? All right, the next part, we've done enough stuff to put it together to actually start running our main. So let's compile the other main and see what it does. It's not very exciting, I have to say. I can add a new email, like interactively. Why not? I don't know what else to put. Draft high. Okay, and I can print it out and stuff like that. Ask for how many there are. Search for things, etc. Now, when I quit, the only thing we've got left to do is, this is what we kind of need to do anytime we've used linked lists at the end of our program, is free all of the data. So free all of the things we've mallocked. Okay? So I just want to go over that a little bit before we try and do it. What's the time? Who wants to recap deletions, and who wants to do the Kahoot now? Kahoot now or delete now? All right. Kahoot. We'll do Kahoot now. We'll do delete after the break when our brains have had a chance to recover. So this does have some deletion stuff in here. So let's see how we go with it. Are you doing the quiz? I did the quiz once and I'd seen the quiz and already done it, and I still didn't win it because everyone's quicker. And also I accidentally pressed the wrong one even though I knew the right answer. Oh, okay. Oh, okay. No, I'm just you're all quicker. Okay. I'll just wait another minute or so for everyone to join. Okay. Yeah, so they're not fixed size. We can malloc and we can add on extra nodes. So you're thinking the fixed size nodes. We call it like a dynamic sort of data structure because we can keep growing it. Yeah, I know, it's a bit. Yeah, things can be interpreted one way or the other when it's words. That's why computing's so good, right? Oh, this one's hard. I'll be quiet. That's good. People have gone well with this. So what we were doing is, this is doing what? This chunk of code is doing what? Do we recognize this? It's finding the last node in the second list. Right? So it's going until current starts here, and it keeps going until we get to the last node, because that's when the next one is null. Now, we should also be a little bit scared of this code, because why would this code make me nervous? Because if these lists, if that list was null, this would crash. All right, in this case, it's not. But it jumps out at me as being terrible. All right, once I find this last node, I'm connecting that to the head of the other list. All right, and then I'm returning this as the head of the list. So now my list has 6, 7, 8. The last node was connected to the first node in the first list, and then I've got 3, 4, 5. Was that what the correct answer said? Yes. Does this make sense? So this is how we can join two lists together. And actually, we'll be doing that today. We'll be merging two folders together. Okay, any questions about that? All right, now that was a tough one to try and just read with a ticking clock. So well done, people who got that right. Yeah, these are the two options. Deleting, it might require free, actually. You might want to remove it from the list, but not actually destroy it. Okay. Yeah, false. If you do it, it'll actually, has anyone accidentally done it? DCC will stop it with a runtime error and say you've freed this twice. It's actually a bad thing to do. Oops. Yeah, that's right. So, yeah, we haven't freed this node. The rest of the logic is fine. So if you print out the list that you get when you delete it, that would have the right data in it. But if you're doing this all the time, you'd be gradually getting memory leaks. All right. And we're going to revise that in a minute as well when we do delete after the break. Green rabbit. Now, we've got a few different sorts of things. Will not compile. I hope that that's not correct. I hope that my answer is correct this time. Will run without crashing, but returns a. Yeah, it's going to have a runtime error. Why? Who knew why and like can tell us? Yeah. Yeah, we're freeing head. So I've got some node, and I'm destroying it. And I'm going into that node and trying to get data from it. So if you run it, you're going to get, you're using malloc data after you've freed it, a message like that, and it's going to give you a runtime error. So,
DCC will not warn us.
Sorry?
DCC will not warn us.
DCC might warn us about things if it realizes that that's what you're doing. Sometimes if you're in the middle of some code, it might not be able to work it out. Okay. All right. Yeah, so if someone feels ripped off by that question because of that, I'm sorry. You can come and get chocolate. Okay, good. So our list has a pointer to the first node in there. So this is like the head of the list. This is kind of like what we've been looking at today with our folder as the list, first as the, emails. Yeah. And also, what would this be like in CS Dungeon? Yeah, map and entrance. You've got something like this, map and entrance, and then you've got linked list of dungeons, right? You've got other linked lists as well. There's more than one linked list. All right, now let's see who the winners are. I'm very sorry, I can't actually pronounce that one. Okay, but well done, Green Rabbit, Excited Panda, the person who came third, the person who came fourth and fifth, who also I didn't have time to read. If you're here, put your hands up. There are some chocolates. Well done. We're going to have a break and come back at about 5 past and look at deletion and keep going with our email system. So, yeah, welcome back from the break. We're just going to recap a little bit. Actually, we're going to spend some time on recapping deletion, actually. So deletion, this is like what we just saw in the Kahoot, actually. We saw some of the wrong ways to do it. This is kind of a way that is correct to do it. So we want to avoid freeing this and then trying to access the data inside it. And we're also trying to avoid ending up with a memory leak. So we're having some kind of temporary variable pointing to here. So once we move the head along to connect it to the next node, which will now be the first one in the list. So if we delete this, oh, I'm clicking things accidentally. What we're trying to do if we're deleting the first node is actually free it, but also connect the list to this node here because that node's gone. So we've got our temporary node pointing to the first node. We connect the head to that next node. Head equals head next. Then we can free this temporary node, all right, without accessing things that have been freed, without having a memory leak. Okay. All right. Now, if I've got a whole linked list that I need to free, what can we do? And this is kind of one of the things we're going to do in this thing today. And I'm pretty sure you have to write this in the assignment as well. Like basically to free up all your sort of linked list data. So if I've got some nodes or emails or dungeons or whatever it is, you know, I've got the head of my list here, I've got current here, and again, there's always slightly different ways you can do it, but you've got to again make sure you're not losing nodes, accessing nodes you've freed, making memory leaks. So here, we've got current, and that's traversing every node in the list. But yeah, we've got current pointing to this node, and the way I've done it is I've said, let's make head equal head next. So this is kind of like what we just did actually. We're moving head to head next. And now we can free current. Now, where do we want current to point to now? Well, what is now the first one in the list? Okay, so we do that again. Head's pointing to here. We say head equals head next. So that makes head point to here. We say free current. That's actually getting rid of the memory associated that we did our malloc with. And now current isn't pointing to anything that it can access. And we just move current along. It's now going to point to head. We do this again. We move head to head next. We free this. And we now move current, to where head is. And at this point, current is equal to null, so the loop stops. And we've freed all of the nodes in the list. If all you did was I'm just going backwards. If all you did in here was say something like free head, all you'd be doing is freeing this one node, and you'd have all of this would be memory leaks. So you've got to go through and free every single node in all of your linked lists. Okay, is everyone kind of happy with that? Now, that was kind of, I'll come back to the other more difficult deletion stuff in a minute, but let's go and put this into our email thing. So,
I forgot, what does current have to equal to head again?
if we say current equals head, we're just making current point to the first node in the list.
We're deleting that as well, right?
So here, why are we doing this? Okay. Shh. I'll just go back to my beautiful drawing. Okay. So if I just do this, if I don't have current and I say head equals head next, I've now got no way to free this node. Right? Head's now pointing here, and I've got no way to free this node. If I try and do it like free, if I try and free head, let me get rid of that. If I've got head and I try and free it and then I say head equals head next, I'm accessing memory that's been freed. So I need two pointers somehow to do this. One to move along and one to free the node. Which order you, like, there's different ways you can do it, but you've got to make sure that you don't do either of those two things. All right, so let's go back to our email management system. I've got clear folder. Now, when we're clearing our folder, again, sorry to be jumping around a lot. Okay, when we're clearing our folder, we've got to clear this whole list, free this whole list, and we've got to free, hang on guys, can you just be quiet? Shh. We've got to free the whole list, and we've also got to free this folder. Which one do we do first? Do we free the folder first, or do we free the list?
The list?
Yeah. If we free this folder, we can't access our email list. Unless, we've got another pointer to it. Yeah. Yeah, that was a good answer. So let's do that. So I'm going to make a function called void free emails struct email, and I can just call it head so we're not as confused. And I'm basically just going to write that code we just wrote again. So it was struct email current equals head, while current is not equal to null. We want to go through every single node. We want to move head along, but we want to be able to free that current node. Then we move current along to where the head is. Hopefully that's the same thing I just typed. We'll find out and we'll debug it if needed. So now I've got that up in this clear folder. I can just call that. I can call free emails. I pass in the head of the list, which is inside this email folder. Remember, that's the head of the list. Just like in the assignment would be map arrow dungeons, for example. Then I can just free the email folder. Because remember, we did a malloc to create that folder. So for every malloc, you need a free. Okay. Now, when I go and run this program, how do I check if I've got memory leaks? Yeah, I compile with -- leak check. So I'm going to run this. I need to at least put a node in. Angela, comp, whatever. Another one. Right, so I do have some nodes in there. I'm going to quit. If there's a memory leak, if I haven't done my freeing of my folder and my emails properly, it's going to tell me. But it hasn't told me that. Now, if I forget one of these parts or do one of these things incorrectly, oh, I don't want to have to type more stuff in. It's going to show me an error. I haven't freed everything. And we're making sure we don't have those because there will be some auto tests and auto marking in your assignment checking for that kind of thing. All right, any questions about freeing and deleting all the things in a list? All right. So this part here is tricky. We went through this the other day. Search and delete. Who remembers doing this? So remember, if I'm trying to delete a node, I need a pointer to the one before it. Why do I need that? Because I need to end up connecting the one before it. Let me draw it. I need to connect this one. Instead of to here, I need to connect it to here. So I need a pointer to this one before it, and then I free this node. Okay. Now the way we did it the other day, and there were two different ways, but this is the way I chose to implement it. We have a previous node that we're keeping track of and a current node. So I've got a previous that starts at null, current that starts at head. And in this example, I'm searching through this list for a particular number. Let's pretend it's 42 that we're looking for. And we either stop when we find 42, or just say we weren't looking for 42, we were looking for 99. We would stop when we got to null because we don't find it. Okay. Now this is sort of a common sort of trick. I want to move previous and current along. So they're one after the other. So I always just move previous to where current is. Then I can say current equals current next. I say let's make previous equal current to move that along. Current equals current next. So this is what this loop is doing. And by the time I've found the thing, if I've found it, by the time I've found it, I've got to point it to the previous node. Okay, and then what I can do is connect this previous node to the next one by saying previous next equals current next. So is everyone happy with this line of code? Previous next equals current next. So the next one after previous, we want to set that to be the one that's currently after next. Currently after current. The next after current, oh my goodness. Then we free it. And then it was done, right? And we noticed a few special cases, right? So imagine I was looking for 13 and I wanted to delete 13. What's the special case here? What do I have to look for? So in this case, imagine I was looking for 13 and I found it. What's special about this situation? Yep. Sorry? Yeah, it's at the beginning. What's previous equal to? Null. So if I try and say, if I've got previous is null, and I'm trying to say previous next equals something, my program's going to crash. So we have to check for that case. What if I don't find the node? What if I was searching for, I don't know, 99? What would current be? Yeah, if it's not in there, current finishes when current is null. So I've got to make sure I'm not trying to delete something that wasn't there. I'm not freeing it. I'm not trying to say current next. I'm not doing anything like that if my current's null. All right, so we wrote code that handled all of these cases the other day, which is kind of, you know, it's definitely not beginner code to write this kind of thing. There's lots of cases where you can mess things up. And we tested it as well. So if we go down into here, search and delete. So we've got this thing we just looked at in the slide, moving previous and current along, having, you know, stopping if we don't find it and reach the end, or stopping if we do find it. But like I said, if current gets to null, we didn't find a node to delete. So we don't want to delete anything, and we can't delete anything. We just have to leave the list alone. So that could happen if the list is empty, or the list might be empty, but it might not have that value in it. So this is all just wrapped up, making sure current is not equal to null. If current's not equal to null, we do have something to delete, but again, we've just got to check this special case if it was the first one in the list, because previous is null. If we don't have this special case and we try and say previous next equals current next, it crashes. So if it's the first one, what are we doing? Well, if it's the first one in the list, this is kind of like when we were deleting the first node in the list. We're just moving the head of the list along to the next one. So we've got that special case for if it's the first one. Then we free it. Regardless of what we're doing, we're returning the head. Now, I know that's a lot of code. We did go over it a bit more slowly in the last lecture. If we tested it, or when we tested it, we had created a linked list with these values in it. We tested to see if we could delete the first one, and it worked okay. We tested it to see if we could delete the last one. It worked okay. We tested it to see if we could delete like 5, which was kind of somewhere in the middle. That worked okay. We tested it to see if we could delete 99, which wasn't in the list. That worked okay. So we decided from that 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 was good enough. Okay. Now, the thing that we didn't do is consider the case where what happens if I want to delete like all of the 42s. I don't just want to delete 142. I want to delete all the occurrences in the list. So what we wrote, so let me go back. I'm going to add some duplicates to this list. It doesn't really matter what they are as long as we've got a few copies of things. Okay, so when I'm deleting naught, I'm only deleting the first naught it finds and then I'm stopping, right? When I'm deleting 9, I'm only deleting the first 9 and then stopping. Does everyone see what this is doing? What do I do to change it if I wanted to delete both of these 9s, both of these 0s, both of these 5s, etc.? What do I have to do? So that's what we're going to do now. Yes, so one really good suggestion is, hang on, I'll just copy this. I'm going to just copy my own code and then change it. So we've got 2 versions here, one that just deletes the first copy and one that can delete all of them. So yeah, the first suggestion is we don't want to have this condition in our while loop because we don't want to stop when we just find the first thing that matches. We need to keep going. We need to check every node in that list to see if it's got that value. We potentially could have to delete every node in the list. We don't know. So we can't have that there. So we need to check for it this is the suggestion, inside the while loop, we have to say something like, well, if current data equals the value that I'm looking for, then I want to delete it. Otherwise, I'm just going to move current and previous as normal. But then, how do I delete it? Well, I'm going to kind of take this code that I've already got here and put it in here. This was the code I tried to use to delete something. Right? I've already got the case to work out if it was at the beginning versus not at the beginning, and I've got a free. I don't need to consider whether current is null because I'm inside the loop that's guaranteeing that it's not null. So I don't need that check. But otherwise, I've got all of this stuff in here that's kind of going to do what I want. What's the problem? Yeah, where's my current? My current, I've just freed my current. Where do I put my current now? So let's go back to a diagram. I've just done this, for example, right? But I need to keep looking because what if the next value or some other value is 42? And I've just freed this. Now, yeah, so that's exactly right. We've got the right answer, but we don't need to move previous, right? Previous is going to be in the correct position. We need to move current. We don't want to say current equals current next because we've freed current, we would be accessing memory that's freed. But we just say current equals previous next and put current here. So this is previous, we're moving it to here. So that was the right answer. Very good. So if we go back to our code, and actually, I'm going to put this in here because we've got a separate thing that we have to do if it was the first node. So if it was in the middle, we do previous next equals current next, free current. And we just said then current equals previous next. Now, obviously, we can't do that if our previous was null. So if our previous was null, so imagine we were trying to delete 13 and we'd said, okay, head equals head next, let's free current. And maybe one of these or some of these have 13. Previous is in the right spot now that we've removed this. Current has to go to where? Well, where's head now? So I've already moved head along to here. So now current just goes to head because I've moved head to head next already. Does that make sense? So it's really going to help you, hopefully, to draw these things and work it out. And it's easier when it's your own drawing than looking at somebody else's drawing too, I think. All right, so let's try that. I'd say current equals head. Now maybe this is wrong, maybe I've made a mistake somewhere, which is fine. It's just that it might take a long time for me to find it in this class. All right, let's try it. Oh, to try it, I'm going to need to actually call that function. Hopefully, if it doesn't crash and it deletes both copies of all these things, we'll feel like it probably works. Do we think it worked? Yeah, so both of the noughts went, both of the nines went, the 2 5s went, and then the thing that we didn't find. What would be a really good test is let's just make everything 0 and then delete 0. Like, does it work if we just have to delete every single thing? Yeah, it did. All right. Does anyone have any questions about this code? It's kind of full on. All right. Does anyone want me to explain the code again? Yep.
This looks big. Like, is there any way to shorten it? Like using functions to remove some parts.
Oh, could we use functions? Yeah, we probably could have something in here to remove something. And there's the other way. So in the slides I showed you, instead of using a previous, you can always check current next, and I didn't implement it. That won't necessarily make it shorter though, yeah. All right, I'll just go through this code. Yep.
I forgot. Why is it that if previous is equal to null, then head is equal to head next again?
Okay.
So it means there's only one thing in the system, right? There's only one previous.
So what this means is, I'm just going to draw something little here. All right. So this is head. This is current. And previous is null. Okay, so just say we were looking for 3. We've set up current to be at the head. We've set up previous to be null, and our head's here. And straight away we go, yep, I'm looking for 3, here we are. Now, if previous is null, this means this was the first node in the list. If it's the first node in the list, something, different has to happen. I'm trying to get rid of this, so this is no longer the head of the list. Do you agree? So this was the head of the list. It shouldn't be now because I'm removing this node. So before I remove it, I say, well, what's the one after this node? That's where the head of the list should be. I want the head of the list to be here. So that's why we say head equals head next. This is head. Head next is this right now. Okay, once I've done that, head's pointing to this second node. But I want to make sure I free this one. So now I say free current. So that is going to free this. That's what this line here does. Is everyone happy with that?
Also in the else statement, why is there current equals to previous next? I thought we free current.
Oh, okay, I'll just keep going with this little part first, just in case other people are still listening to this part. And then I'll talk through the next one as well. Now, we've just freed current, but we've got to now move current along to head. And previous is still equal to null. Our head is here, current is here, and we're ready to keep going. All right, now in this situation, let me add another node. Doesn't matter what's in it. Null. Okay, so we're up to here. We're going again. Is this equal to our value? And it's not, right? So we're moving previous to current. So previous will now be pointing to here. Current is going to current next. So in the case where it wasn't equal to anything, we just update prev and cur. Is everyone kind of happy to hear? Now, the next time through the loop, remember we're looking for 3 in this example. Is this node, does it have the data value of 3? Yes. Is previous equal to null? No. So now we're in this chunk here, which is the chunk of code that handles deleting a node that's not the first node in the list. So we want to connect this node to this node because we're going to get rid of that node that's in the middle. So we're saying previous next equals current next. So this is current. This node, we can refer to that as current next. Right now, the next one after the previous node is current. We don't want that to be the case. We want previous next to be current next. So that sets this particular pointer here. Is everyone sort of happy with that? Now we can free this. So we're freeing, oops, wrong button. We free current, and that's great. Our list is connected. We've freed the current, but because we're still going on and looking for more, we have to set current to something. Well, this one here is previous. We don't want to put current there. We want to set it to the one after current, which is previous next. So we say current equals previous next.
So that current can equal to null, and
Eventually current will be equal to null, and then we will finish the loop, right? So next time round, we'll be checking, well, that's not equal to 3. We'll be moving previous to point to this one here, and we'll be saying current equals current next, and current will be equal to null, and this whole loop will stop. Okay. Does anyone else have any questions? Or do you have a question?
a bit kind of confused.
While you work out what your question is, I'll just answer this question. Yep.
I was just wondering where we initialized the current as equal to the head, like at the very start, or like where current is, what current is initially defined as.
Oh, so current, let's just go up to here. So yeah, current, we've set it to the head just like we kind of do all of the time. And yeah, because I haven't shown you the whole thing. So current, usually we'd just say current equals head and say current equals current next and move it along one by one. But in this case, because we're deleting things, we can't just do it like that because we're freeing current. We have to work out how to set current some other way. The other way, you could have another variable called temporary or something. There's different ways you can do it. But yeah, does that make sense? What part of the code did you have a question about, or are you not sure? Do you want to ask now or later? It's up to you.
So current equals to previous next is just to move the current along for our
Yeah.
while loop, right?
Yeah, that's right.
In the else statement, now that I look at it, why is there previous equals to current? Why can't we just have current equals to current next again?
Okay, so the question is, why can't we have, are you saying why do we have this line here?
No, the one below. Previous equals to current.
Oh, why do we have that? We always want to, this is for the case where we haven't just deleted something. In the case where we haven't deleted anything, we always want to move previous to current. Like if we just haven't found something, we want to move previous to current and say current equals current next. Previous equals to current, current equals current next. When we've found something to delete, that code's not going to work. We have to do something different. Yep. So that's the pattern. If we didn't find anything, we'd just keep doing that until we got to the end of the list. All right. Let's actually, what I'm going to do, I'm going to steal this piece of code. Not steal it, copy it and paste it. Being dramatic. Because we're going to do something like this in the email thing. Now, in this email thing, we're doing delete email with a given priority. So priority is just a value that we're looking for in this linked list, and we want to delete all of them. So we need this one that doesn't stop when it finds one and deletes it, keeps going. Now, we don't really have head of the list. Remember, we've got email, folder, emails, right? Oh, and these aren't called nodes anymore. They're called struct email. All right. No, data's not called data. We're looking for priorities. And again, head is not called head. Our head's in this struct. Okay, but the rest of the code, is the same. All the logic's the same. Hopefully, if I just slot that in like that, that will work. Let me think if there's a no, it won't work. What am I doing that's silly here? Yeah, it's a void function. I don't have to return the head of my list because it's being updated and stored in that struct. We've got that extra struct that is storing the head of the list, so we don't have to keep returning it. Let's see if this works. First of all, I'll move to the correct folder. And I'm trying to compile the test main. All right, now there's a giant lot of text coming out of here, but what we were trying to do was to delete any of the low priority emails from our folder 2. So let's go to our main, not that main, test main. Folder 2 had these particular emails. So we should see that after we delete the low priority ones, this should be deleted, this should be deleted. And remember, we had inserted them at the head, so it would have been in the opposite order. But we should have Olivia left with normal priority, Chloe with high priority. We should have 2 emails left. Yeah, and we do. Yep, so that looks right. It looks like it deleted all the low priority emails. Okay. What's the time? All right, we've got time for another one. I know you're all so elated by that. What's the next one? This one here is called merge folders. Now, this is a little bit like what we did in the Kahoot as well, a little bit. So, okay. So imagine this scenario. I've got 2 folders that have emails. I actually want to create, or I've been given, I'll have to check, a 3rd folder. And I want the 3rd folder's emails to have all the emails from the 1st folder connected to all of the emails on the 2nd folder. So I want to join the 2 email lists together into one. They should be connected to this new folder, and we want to free this memory here. Those folders are empty, we don't want them. Okay, so this is what we're trying to do. Now, how do we do this? What's the step in joining these 2 email lists together?
I think we'll need 2 structs for 2 of the heads.
So like pointers.
Sorry, pointers to 2 of the heads.
So yeah, we will have that in the folder. How do I join what node do I need to find in the first list? I need to find the last node in the first list, and I want to connect that to the first node in the second list. Yeah, we're not making a copy, by the way. We're not making a copy of all of these things. We're actually just basically moving all of these, not moving them, we're connecting them up to a different folder and destroying the original folders. We're not making copies of all the emails. That would be more work. We'd have to go through everyone and copy it. Here we're just, changing a couple of pointers around. That's right. So let's try it. Okay, so first of all, I need to create the new folder that I'm going to attach it to. So struct folder I'm just going to call it new folder. And if we're careful, we remember that we've already got a folder creation function. So we don't want to like write all that code again and do our mallocs if we've got a function we can use. So this, I'm passing in merged folder name. All right, so that's mallocing and creating my new folder with the correct name. And the email list inside that should be null. Now, I want to find the last node of the first list. Now, hopefully, this is going to look familiar to you. We don't have head. We're looking in the first folder. That's the head of the email list in the first folder. And to find the last node, when do we stop? So if we want to go through the whole list, we do something like this. If we want to stop at the last node, we do something like this. This is going to stop us at that last node. Now, once we get to that last node, we're connecting it to the first, we want to get this connection here. So this last node's probably pointing to null, you would imagine. This has to point here. So this would be folder 2, arrow emails. So let's have a go at doing that. So we say current next. So right now we're at the end of email list 1, but we want to connect it to the email list 2 in folder 2. So that would connect them all up together. And now we want to put that email list in our new folder. So new folder, I've got to make sure I set that to yes, folder 1. My brain's not coping anymore. Like this. So basically folder 1 at this point has all the emails in it connected to all the emails in the other one. And there's still a few issues here, and basically I want to return my new folder that has all of this stuff connected together, and it's pointing to that whole new email list. Now, is this line here screaming anything to anybody? Yeah, what if current's null? This is what this line should always be screaming at you. What if current's null? So, well, we kind of do want to do this, but what do we always just do? We have a special case. The special case here would be if folder 1 has no emails in it. If folder 1 has no emails, yeah, all of the emails are just coming from folder 2. So we can just have a case if folder 1, I'll do it like this. If folder 1 emails is null, well then there's none in folder 1. So our new folder it has all of the folder 2 emails. Now, if you're thinking, but what if there's none in folder 2 either? That's fine. We would just be setting the new folder's emails to be null in this situation. What we can't do is say null arrow next. So this is the special case for if the first folder has nothing in it. And this is the case for the first folder has something in it. Does that look okay? What else do we have to do? So we've still got these folders hanging around, and this one's still connected to this, and this one's still connected to this. So we've got a lot of weirdness happening. We also want to just destroy them. So what we should probably do so we don't have memory leaks, yeah, is just free them. We don't want to go and free all the nodes in them because they're still connected to the very nodes that we've connected up to our new folder. So we don't want to go and call our function that frees all the nodes in the list. We just really want to free these folders, the actual structs that are pointing to these linked lists. Now, that's the idea. Does this compile and run? We don't know yet. And does it work if it runs? Honestly, oh yeah, that's correct. That's correct. You might want to take my word for it because there's a lot of data being printed out here, but there was supposed to be the original ones from folder 1 with the ones we just, from folder 2 after we deleted the low priority ones. Yep. I think we're running out of time. There's one main thing we didn't do yet. This time, instead of merging things, we've got one folder with all of the emails. We're trying to break it up. So if an email is this one high priority, draft. So we're splitting it up into 3 different folders. Draft, received is the inbox, and sent. So we're not going to have time to do it, but it's going to be a little bit like one way you could do it is just go along one by one, kind of deleting from the first list but not freeing it, and inserting it at the tail of the appropriate list. So if current type equals draft, insert at the tail of draft. And then you'd have to write something to insert at the tail. I'll put the solution that has split folder in it up. Before you go, I just want to do a quick poll about what we're going to do in the next lecture. So the options basically are start exam revision and talk about the exam and all of that sort of stuff, or do something that's not in the exam just for the sake of it, like recursion. No, okay. Well, but I just want to make sure everybody, the majority gets the thing. Is there a poll up? Okay, so answer the poll. If you feel strongly, answer the poll. Because it might be all the people that are really keen for the other option that are answering.
Ask about
Yeah?
this stuff. So where would it be held?
Oh, look, that's not through me. Email this student. He's like a master's student. Just email him and ask him where it would be held. It might be on Teams or it might be in person. I'm not sure. But email, if you're interested, email him. That would be awesome. But yeah, don't feel like you have to do it for this course, just if you want to do it.
I just want to get the $20.
Ah, nice, nice.
I was wondering, why did in the last piece of code you had to create a new folder, a new struct?
Because that was the question. It said, what? Right, we could have just changed the name inside the other struct.
Oh, no, I meant as in you had one that checks like folder 1 if
Yep.
it's equal to null.